Okay, chapter 10 is about wave properties of particles. So 10.1, the de Broglie wavelength. So 10.1a state the wave particle duality. Wave particle duality is phenomena where under certain circumstances, particles exhibit wave properties and under other condition, a wave exhibits properties of particles. So it means that nak cakap yang particle wave duality ni dia boleh bersifat dua nature ataupun kita kata dua alam lah. Okay, from the relationship of de Broglie and Einstein relativity, photon has the momentum proportional to its energy, and from the Planck quantum theory, they said that energy of the photon is given by E equal to hc over lambda. Okay, based on the Einstein special theory of relativity, so the energy of photon is given by E equal to mc square, and P momentum is equal to mc. So whereas E is equal to PC, and then they combine these two, and then they come out with the equation yang baru with the P is equal to H over wavelength, where P is show that the particle properties and the wavelength is about wave properties. Okay, so this equation illustrate wave particle duality like having both properties of particles and wave lah. Sebab sebelum ni kita buat more about light lah. Okay, the table show the experiment evidence to show wave particle duality of light is about wave. Kita buat eksperimen yang double slit, and diffraction experiment. Bila wave tu bersifat partikel, kita kaji kita tengok orang buat kajian tentang photoelectric effect and quantum effect. Okay, based on the wave particle duality of light, Louis de Broglie suggested that the matter such as electron and proton might also have the dual nature. So dia pun cakap lah, sebab kita tahu electron and proton itu adalah satu partikel, so adakah dia boleh juga bersifat sebagai wave? Okay, so he proposed that for any particle of momentum P should have a wavelength. That wavelength is show what we call it as wave behavior. Okay, so based on equation de Broglie wavelength, de Broglie wavelength is equal to H over P, where P is equal to mv. V is state for the speed of particle. Okay, mass is mass of particle. If let's say kita kata particle tu adalah electron, so mass ni will be mass of electron. Kalau particle tu adalah proton, so mass will be mass of proton. Macam tu lah. Okay, then de Broglie relation was confirmed in 1927 when Davison and Germer succeed in diffraction electron, we show that the electron have the wave properties. Ni lepas dah buat eksperimen. Okay, so properties of particle and wave. So particle, dia punya properties is tiny object like bullets, electron, proton and neutron have mass, obey Newton's law, and when in motion they have a momentum. But about wave properties is travel continuously, exhibit wave properties like diffraction, interference and reflection. Okay, and have a wavelength also. Okay, next is 10.2 about electron diffraction. 10.2a describe the observation of electron diffraction in Davison-Germer experiment. So Davison-Germer experiment was set up like this, and then we can see that the pattern is the ring. Okay, ring pattern. So the distance between this ring is wavelength. Okay, so a beam of accelerated electron strike on a layer of graphite which is extremely thin and diffraction pattern consisting of a ring seen on the tube face. This experiment proved that the de Broglie relation was right and the wavelength of the electron is given by equation lambda is equal to H over mv. Whereas if the velocity of the electron is increased, when the velocity is increased, so we can see that the wavelength is decreased. Wavelength means that we can see that the ring are seen to become narrow, showing that the wavelength of the electron decrease with the increasing velocity as predicted by de Broglie. So means that kalau velocity tinggi, so maka ia akan nampak jarak antara ring tu semakin narrow. So means dia menunjukkan bahawa wavelengthnya berkurang. Okay, right. So the velocity of electron are controlled by the applied voltage V across the anode and cathode. So U is equal to K, where U is equal to EV, K is equal to half mv square. So rearrange the equation, we can see that the speed is equal to cert 2 EV over M, where V is a potential lah. Potential, okay. Yang ni V apa? Velocity lah. Ataupun kita kata speed pun boleh. Okay, cuma beza dia arah, tak ada arah je. Okay, then by substituting the equation 2 into equation 1, equation 1 ni lah basic equation. Equation lambda is equal to H over mv. Okay, so substitute EV in this. So we get lambda is equal to H cert 2 MeV. So kat sini kena hati-hati because this equation is 2 mass of particle. E adalah elementary charge 1.6 times 10 to the power of negative 19, and V ni adalah potential, electric potential. Okay, so electric potential. Jadi dekat sini you kena hati-hati. Kalau you nak kira EV ni, you boleh ganti dengan E ataupun K lah. So you boleh tulis formula yang baru, lambda is equal to H over 2mk. Kita kebanyakan kita guna energy dalam case ni adalah kinetic energy lah. Okay, so K di mana K is equal to EVS. Okay, so jangan salah faham lah.